Hello, and welcome to this fourth Chalk Talk in our series on Agile data integration. In this third step of our data integration process, we're going to take a look at how the developer and the analyst work together to identify the join conditions and data quality rules that are required to meet the business requirements. This is actually one of the more time-consuming steps, in that it's not always an easy task to determine how to join disparate data sources, especially as you end up having more than two. Then it gets even more complex. Typically, one of the first steps involved is a developer is going to search the documentation to find out potentially if there's any documented primary keys or even foreign key relationships as part of the schema. And if these data sources are coming from different applications, then the job even becomes more difficult. And it requires the developer to, in some instances, create SQL scripts to profile the table, get a better understanding of what potentially could be that primary key based on uniqueness or the lack of null values. And then also look at potential foreign key relationships by comparing values and metadata such as column names. Now, this is somewhat of an ad hoc approach, and therefore it's iterative in nature because it's done through trial and error. The developer, once they identify the primary key of, say, the driving table, will also look for these foreign key relationships and try and figure out some ways to join these two data sources together. One method is to try out some lookups, filters, transformations in order to meet the join conditions. And then the developer will come up with some candidate entity relationship model that can be shared with the analyst to see if it does in fact meet the business requirements. Now, once the entity relationship model has been verified, the analyst and the developer can work together to resolve the data quality issues that were identified in the previous step. This requires the developer to write a script to resolve the data quality issues. And in fact, the developer or some other developer may have written a similar script from a previous project. And therefore, you're basically reinventing the wheel in this case. The analyst will check that the data quality rule does in fact fix the issue. And in some cases, the data quality issues are just too complex to resolve, and therefore you need to go back to the business and go back to prior steps to see if you can identify some other data sources that might work better. Some opportunities to improve this process include cross-table profiling and join analysis directly within the data integration developer tool. Another way to improve the process is to be able to search a common metadata repository for data quality rules that have already been created, so that you're not, one, reinventing the wheel, and two, data quality rules can be applied consistently across projects, across data sets. Now let's take a look at how we can improve the process. Informatica provides the ability to infer both primary and foreign keys directly within the developer tool. The developer can also confirm the join conditions work by doing join analysis. You can identify orphan rows and find redundant values in other tables. As these primary and foreign keys are identified, you start to build out a model that can be reviewed and shared with other developers and other stakeholders. Let's take a closer look at how this is actually accomplished. Here we are within the developer tool. I'm going to create a profile. In this case, it will be a profile model. We'll give it a name. and we've specified a repository. Now we're going to select the objects in our model. In this case, we're going to choose customer object. We'll look for an address table, and we'll also add a product table. Now the challenge here is to first identify the primary key in the customer table and to identify the primary and foreign key relationships between the customer and product table and customer and address table. First, let's see if we can identify the primary key of the customer table. So we will try column primary key profiling. Some inference options allow us to specify the number of key columns within the profile and also the number of rows to sample. We can select whichever columns we want to include in the profile. And now let's take a look at the results. We see some good candidates here. The best candidate looks like customer number, so let's validate that by profiling the entire data set. Still looks good. Over 99% conforming, so we're going to use that as our primary key for the customer table. And then we can use a similar approach to identify the primary and foreign key relationships between each of the subtables. Now let's take a look at how we can find and apply some data quality rules to fix the issues that we uncovered. Here we are back in the Informatica Analyst tool. We're going to look for some address cleansing data quality rules. In particular, we're looking for one to standardize on the country name. We see here that there's a rule to standardize on the country name. Within the Informatica Analyst tool, we can look at the description and what it does. We can look at the input values and the output values that are required. But essentially, the analyst can treat this as a black box without having to understand the underlying complexity of how this data quality rule is actually executed. So, the analyst has found a rule that is going to work, they believe, to fix this data quality issue. And they can actually validate that it does in fact fix the issue directly within the Informatica Analyst tool. Now let's take a look at what this data quality rule looks like within the developer tool. Here we see all the different steps involved in executing this data quality rule. The great thing is this same rule can be applied consistently across projects and across data sets so that you ensure that addresses are standardized and cleansed in the same way. And that concludes the fourth Chalk Talk in our series on Agile data integration. Thank you.